Good day, dear learners. In this video, we will learn about light, propagation of light, reflection, and refraction, as explained by the wave and particle models. The objective of this video is to, number 1, explain the wave and particle models of light. Number 2, describe reflection and refraction in terms of the wave and particle models of light. Number 3, explain the propagation of light using the wave and particle models. So, let's begin the discussion with the theories about light. Before, there is a debate whether light is a type of wave or a flow of extremely small particles. So many theories has been made about this. One of those is from René Descartes. He believed that light was a mechanical property of a luminous object and a transmitting medium, and that state that light can be transmitted to any medium or any luminous objects, such object that can be reproduced and generate light. This also states that refraction can be determined by the speed of light in different objects or media.
In 1704, Isaac Newton brought forward the corpuscular or the particle theory of light. In this theory of Isaac Newton, he proposed that light is composed of particles of matter called corpuscles, which are emitted in all directions from a light source. Newton assumed that these corpuscles travel in a straight line at high speed. Then these corpuscles are different in size, in colors, and forms image of object when these corpuscles heat enter the eyes. Here is a short clip that may help you to better understand Newton's corpuscle theory of light.
Newton's corpuscular theory of light states the following. Light consists of corpuscles, which are a stream of discrete, tiny, light, and perfectly elastic particles. Every luminous source, like the sun, a lamp, or a candle, emits these corpuscles. These corpuscles travel in straight lines in all possible directions. The rate at which these corpuscles travel may differ depending on the medium in which they disperse. The vision of human beings is a consequence of these corpuscles falling on the retina of the eyes. Various colors of light are due to the difference in sizes of these corpuscles. These corpuscles could perfectly explain the concepts of reflection and refraction of light. The reflection of light, which consisted of corpuscles, is just like the reflection of a perfectly elastic ball.
In summary, the proponents of the particle theory of light pointed to reflection as evidence that light consists of individual particles that bounce off objects, much like a perfectly elastic ball. Newton believed that refraction could be explained by his laws of motion, with particles of light as the object in motion.
The wave theory of light was proposed by Christian Huygens in 1678, which states that light is made up of waves. Huygens assumed the following concept in his wave theory of light. First, light coming from a source sends out waves in a medium called ether. A medium is not necessary for the propagation of waves. Second is, light is a form of energy and has wave characteristics. And the last one is, light wave has short wavelengths. Wavelength, the distance between any two consecutive crests or troughs, is known as wavelength of the wave. It is represented by the Greek letter lambda. Here is a short video that may help us to further understand Huygens' wave theory of light.
Huygens' wave theory. According to Huygens, light is propagated in the form of waves through a continuous medium. Huygens assumed the existence of an invisible elastic medium called ether, which pervades all space. The disturbance from the source is propagated in the form of waves through space, and the energy is distributed equally in all directions. Huygens assumed that these waves to be longitudinal. Initially, rectilinear propagation of light could not be explained. But the difficulty was overcome when Fresnel and Young suggested that light waves are transverse. The wave theory could satisfactorily explain all the basic properties which were earlier proved by corpuscular theory, and in addition, it explains the phenomena of interference, diffraction, and polarization. According to Huygens, the velocity of light in a denser medium is less than that in a rarer medium. This is in accordance with the experimental result of Foucault.
Light can be quite tricky, so let me shed some light on its dual properties. Alright, so here's the deal. When light decided to act like a tiny particles, it travels in a straight lines. Para siyang sumusunod sa road signs. No detours or shortcuts. So kapag may obstructions tulad ng pader o anumang harang, nagpo-produce ito ng anino or shadows. In the image, there are tiny particles traveling through it in straight lines. This represents the particle-like behavior of light, where light can behave as individual particles called photons. These photons travel in straight lines until they interact with an object or surface. The straight lines of the particles in the image symbolize how light travels in a straight path until it encounters an obstruction or gets reflected, refracted, or absorbed by an object. This behavior is a characteristic of light as a particles. Pangalawa, we have its wave-like behavior. Parang bula na kumakalat. Light can travel in waves, just like when you throw a stone in a calm lake and you see those ripples. It can bend, diffract, and interfere with other waves. Kumbaga, it behaves like a smooth wave moving through space.
So let's move on to the reflection and refraction of light according to particle and wave theory. Light arrives at the surface of the glass as a stream of particles, so the case for the particle nature of light is longer with respect to the reflection and phenomenon than refraction. So, yung liwanag na inilalabas ng isang pinagmulan malapit man o malayo ay dumarating sa ibabaw ng salamin bilang isang stream of particles, which bounce off or are reflected from the smooth surface. Light as wave upon impacting a mirror bounce off or reflect according to arrival angles. According to wave-based theories, the light waves spread out from the source in all directions and upon striking a mirror, are reflected at an angle determined by the angle at which the light arrives. The reflection process ay binabaligtad ang bawat alon pabalik sa harap, kaya naman ang isang reverse na image ay sinusunod. Light as wave change direction upon passing from first medium to second medium. Refraction is the bending of the path of a light wave as it passes from one medium into second medium. The refraction occurs at the boundary and it is caused by a change in the speed of the light wave upon crossing the boundary. So let's move on to the refracting particles of light change direction upon passing between two media. When a beam of light travels between two media having different refractive indices, the beam undergoes refracting and change direction when it passes from the first medium into the second. So, para matukoy kung ang sinag ng liwanag ay binubuo ng mga wave at mga particle, ay may isang model para sa bawat isa na maaaring gawin upang ipaliwanag ang phenomenon. So next is reflection produce different type of image, virtual or real, depending on the reflecting surface. Real image are formed when light rays after reflection or refraction converge at a point before a mirror or lens. Habang ang habang ang virtual image ay nabuo ng isang sinag na liwanag ay nagkakaiba pagkatapos ng reflection and refraction. And about the real image appear on the screen as against virtual image na na hindi kailanman nag-a-appear on the screen. Plane mirror produce specular or regular reflection. In this case, the light rays are reflected from a smooth, shiny, or polished surface like that of a mirror and are reflected by a definite angle. Dito, yung incident ray at reflected ray ay gumagawa ng parehong anggulo na normal. Then, yung pagbuo ng isang image ay dahil sa regular na reflection. The image distance and object distance in the mirror are equal. For plane mirrors, the object distance is equal to the image distance. That is, the image is the same distance behind the mirror as the object is in the front of the mirror. If you stand a distance of 2 meters from a plane mirror, you must look at the location 2 meters behind the mirrors in order to view your image. Convex mirror is a spherical mirror with reflecting surface that curves outward. The convex mirror has a reflecting surface that curves outward resembling a portion of the outside of a ball or sphere. Light rays parallel to the optical axis are reflected from the surface in the manner that diverge from the focal point which is behind the mirror. Convex mirror produce virtual image that are reduced and located behind the mirror. Convex mirrors produce virtual image that are located somewhere behind the mirror. It is considered a virtual image because light does not actually pass to the image location. Lumilitaw lamang na dahil sa pagpapakita ng liwanag na nag-iiba mula sa virtual location image. Concave mirrors are spherical mirrors with reflecting surface that curves inward. A concave mirror has a reflecting surface that curves inward, away from the incident light. Concave mirrors reflect light inward to one focal point. They are used to converge light. Unlike convex mirror, concave mirrors show different image type depending on the distance between the object and the mirror. Concave mirrors produce mostly real and reduced image but can also produce virtual image depending on the location of the object. So, the real image are produced when the object is located a distance greater than one focal length from the mirror. A virtual image is formed if the object is located less than one focal length from the concave mirror. A real image is produced when an object is located in between the focus and reflecting surface. When an object is placed in between the center of curvature and focus, the real image is formed behind the center of curvature. The size of the image is larger than that of the object.
Propagation of light is the process by which an electromagnetic waves transfer energy from one point to another. It is referred to as a light propagation. To understand the propagation of electromagnetic waves are created as a result of vibration produced between an electric field and magnetic field. Sa madaling salita, ang electromagnetic waves ay nai-emit ng isang accelerating electrical charge. Ang mga waves na ito ay may mga uri ng traveling at magnetic transverse waves. This wave is oscillating or vibrating, so this wave has both the magnetic and the electric field component, and this is traveling at a speed of 299,792,458 meter per second in the vacuum of space. Bukod pa dito, ang iba't ibang electromagnetic wave ang siyang bumubuo sa tinatawag nating electromagnetic spectrum. Ito ay nagpapakita ng frequency at wavelength ranges ng mga electromagnetic waves. Ang electromagnetic spectrum ay binubuo ng radio wave, microwave, infrared, visible light, ultraviolet, X-ray, at gamma rays na kadalasan nating ginagamit para sa communication, medical treatment at diagnosis, at scientific observation. Mahalagang tandaan natin na ang radio waves ay ang may pinakamababang wavelength at ang gamma rays naman ang may pinakamaikling wavelength. Ngunit ang gamma rays naman ang may pinakamataas na frequency energy at ang radio waves naman ang may pinakamababang frequency energy sa lahat ng magnetic waves. Next is dispersion. Ito ang paghihiwalay ng mga components ng visible light sa spectrum nito dahil sa pagkakaiba ng kanilang degrees or refraction. Light can be absorbed or transmitted. When light falling on smooth surface, it produces image that our eyes can perceive. Recognize natin ang color due to the observation in the reflection of light certain wavelength or colors. If seeing an object of white, that means all the colors are reflected. If we are seeing a black object, that means that all the wavelengths or color of white light.
So, here are the summary of the things that they had discussed. The corpuscular and wave theory of light were proposed by Newton and Huygens respectively. Light travels at 3.0 times 10 to the power of 8 meters per second in the vacuum of space. White light is composed of light waves of different wavelengths or colors. Light can be reflected, refracted, and absorbed.
And that's all for today's lesson. We hope that you learned something in this video. Goodbye and take care.